Dan Perry here with another Dan on Tech Python video.
In the last video, we looked at a program where what we did was we compared numbers and we looked at the different inequalities and equalities, all 6 of those combinations we had, and we compared numbers to see if the numbers were equal or not equal. And I think that was relatively obvious on what the output would be. This time what we're going to do is we're going to compare not numbers but strings, and we're going to do just a simple 1-character string, and I've started with X and Y both being a capital A. Now, well, equal and not equal probably makes sense. The greater than or equal, less than or equal makes sense, but can a character be bigger than another character? Well, let's see. The first time X and Y are both the letter A, so in it we would expect them to be equal. We would also expect them to be greater than or equal and less than or equal. So those 3 statements are the ones we expect to be true. So when I run it, well, that's what I get. A equals A is greater than or equal to A is less than or equal to A. So those are the 3 true. A not equal to A, well, no, you'd expect those to be true. So let's try changing from Y and make Y a B. Now, we'd expect a not equal. We would expect it to not be true for equal. What about the greater thans, less thans? Well, let's see what happens. Well, it says A not equal to B. We expected that. A less than B. A less than or equal to B. Well, how can a letter be greater than or less than another letter? Well, letters are stored as bytes. They're stored in a code called the ASCII code, and each letter is stored as 8 bits or 1 byte. So there are 256 possible combinations of the ASCII code. When we look at the ASCII code, what I've got is a table, and it's got actually the decimal equivalent to the binary, that base 2, those 8 bits, the hexadecimal and octal, and then what the character is. Now, some of these characters are not printable. There's control characters, such as the tab, the form feed, which on a printer would send the printer to a new page. So some of those are not printable. Then we get over in this second column, and we start getting to the printable characters, and we start with a blank space. Then we've got some special characters. Then we've got digits, 0 through 9, some other special characters, capital letters, and lowercase letters. And if we look at the decimal equivalent to those binary numbers, we see that they keep increasing. 32 for a space, 48 for a 0, 65 for a capital A, 97 for a lowercase a. And that's how we know if one is larger than the other, whatever their binary number is, whichever is larger, or the decimal equivalent in this case. So if we look here, a capital A was a 65, a capital B is a 66, so that would say that a B had to be greater than an A, and that's what we got when we ran it. Now, what about those lowercase letters? Is a lowercase a greater than or less than a capital B? And when we run it, what we see is that a lowercase a is not equal to B. We'd expect that. But a lowercase a is greater than a capital B. Well, it comes earlier in the alphabet, an A before a B. So why is it greater? Well, we go back to that ASCII table, and we see that we've got that 66 for the B and 97 for the A. So all the capital letters have a lower value than the uppercase letters. Now that's important when we want to sort or test things. So if you need to get something in alphabetical order, you might need to test it. If you need to sort it, see if something is in sorted order, you might need to know that. Now, you don't want to memorize this table. What you want to do is look it up if you ever need to know exactly where things go. What I recommend is to know that the blank space, then digits, capital letters, and lowercase in increasing order. And if you need to know where any of the special characters fit, look it up.